Are you ready to explore the wonders of the universe and discover the surprising diversity of planetary systems? Join us on an interstellar journey as we delve into the fascinating world of exoplanets and uncover the remarkable variety of planetary systems beyond our solar system. From hot Jupiters to super-Earths, multiple star systems to rogue planets, prepare to be amazed by the incredible range of configurations and characteristics of these distant worlds. Don't miss out on this captivating video on the surprising diversity of planetary systems. Watch now and expand your horizons. What are planetary systems? A planetary system is a set of gravitationally bound non-stellar objects in or out of orbit around a star or star system. Generally speaking, systems with one or more planets constitute a planetary system, although such systems may also consist of bodies such as dwarf planets, asteroids, natural satellites, meteoroids, comets, planetesimals, and circumstellar disks. The Sun, together with the planetary system revolving around it, including Earth, forms the solar system. The term exoplanetary system is sometimes used in other planetary systems. As of 1 March 2023, there are 5,332 confirmed exoplanets in 3,931 planetary systems, with 855 systems having more than one planet. Debris disks are also known to be common, though other objects are more difficult to observe. A surprising diversity of planetary systems. The remarkable diversity of planetary systems that we are discovering. We're finding lots of things that we didn't see in our solar system. There's a class of planets that we've gotten very excited about called SuperEarths. These are rocky planets with masses whose masses are greater than the Earth and less than Jupiter, Saturn, Uranus, or Neptune. Uranus is about 10 times the mass of the Earth, and in our solar system, we don't find any 2 or 3 Earth-mass planets. Yet when we look at what Kepler has found, these are the number of Earth-sized planets, and these are the number of super-Earth and Neptune-sized planets. We can see a lot of what Kepler found as planets, whose radius ranges from about 1.5 times to 6 times the Earth's radius. This class of objects, super-Earth and Neptune-sized planets orbit Earth or Venus, is a class of objects that we've not seen before, and one of the things we're trying to understand is what would these planets be like. Trying to imagine these objects larger than the Earth. Do they contain lots of water? Do they have plate tectonics? Do they have hydrogen-rich atmospheres? What are their properties going to be like? And this is an area of very active study. We've not yet been able to characterize many of these super-Earth systems. So what we've done so far is build theoretical ideas about what their properties might be like. Diversity of planetary systems in low masses. The diversity of planetary systems that might form around Sun-like stars in low-mass disks without giant planets. We focus on the formation process of terrestrial planets in the habitable zone, HZ, and analyze their water contents to determine systems of astrobiological interest. Besides, we study the formation of planets on wide orbits because they can be detected with a microlensing technique. And simulations of high resolution, embryos plus planetesimals, are developed for a wide range of surface density profiles. The surprising diversity of planetary systems refers to the wide range of configurations and characteristics observed among the exoplanetary systems that have been discovered outside of our solar system. These exoplanetary systems can vary in terms of the number, size, and orbital properties of their planets, as well as the types of stars they orbit and the overall structure of their systems. Some exoplanetary systems are similar to our solar system, with rocky, Earth-like planets orbiting relatively close to their parent star and gas giants farther out. However, other systems have been found to have hot Jupiters, gas giants orbiting extremely close to their star, or super-Earths, planets with masses larger than Earth, but smaller than Neptune. Additionally, some exoplanetary systems have multiple stars, with planets orbiting around 2 or more stars, while others have planets with highly eccentric or tilted orbits, or even orbits that take them through their star's atmosphere. Overall, the diversity of planetary systems that have been observed challenges our previous assumptions and models about how planetary systems form and evolve. It also raises intriguing questions about the potential for habitable planets and the existence of extraterrestrial life in our galaxy and beyond. Planetary diversity. The experimental Terapascal perspective. The discovery of extrasolar planets orbiting other stars has been one of the breakthroughs in astronomy over the past decades. Exoplanets are common objects in the universe, and planetary systems seem to be more diverse than originally predicted. The use of radius-mass relationships has been generalized as a means for understanding exoplanets' compositions, in combination with equations of the state of main planetary components extrapolated to Terapascal (TPA) pressures. In the most current description, Earth-like planets are assumed to be fully differentiated and made of a metallic core surrounded by a silicate mantle, and possibly volatile elements at their surfaces in supercritical, liquid or gaseous states. This model is currently used to infer mass-radius relationships for planets up to 100 Earth masses, but rests on poorly known equations of states for iron alloys and silicates, as well as even less known melting properties, at providing experimental references for equations of state and melting properties up to TPA pressure range. With the combined use of well-calibrated static experiments, laser-heated diamond anvil cells, and laser compression experiments capable of developing several MAR pressures at high temperature, coupled with synchrotron, or XFEL X-ray sources. Different diversity of planetary systems. Several types of planetary systems exhibit diverse configurations and characteristics. Some of these are solar-like systems. These systems resemble our solar system in terms of having a central star with multiple planets orbiting around it. These planets can range in size from small, rocky worlds like Earth to larger gas giants like Jupiter and Saturn. Hot Jupiter systems. These systems have gas giant planets that orbit very close to their parent star, resulting in extremely high temperatures on the planet's surface. SuperEarth systems. These systems have planets that are larger than Earth but smaller than Neptune, and can have a variety of compositions, from rocky to gaseous. Multiple star systems. These systems have planets that orbit around 2 or more stars, which can create complex and sometimes unstable orbits. Eccentric and inclined orbit systems. These systems have planets with orbits that are highly elliptical or tilted, which can result in extreme temperature variations and other unusual characteristics. Rogue planets. These are planets that do not orbit around a star, but instead drift through space on their own. Circumbinary systems. These systems have planets that orbit around 2 stars that are in a close binary orbit around each other. The diversity of planetary systems challenges our understanding of how these systems form and evolve, and raises important questions about the potential for habitable planets and the existence of extraterrestrial life. The study of exoplanetary systems has shown us that the universe is full of surprises, and the surprising diversity of planetary systems is a testament to that. From hot Jupiters to super-Earths and rogue planets, each system offers a unique glimpse into the vastness and complexity of our universe. By continuing to study and explore these systems, we may one day uncover the secrets of how planetary systems form and evolve, and ultimately discover the existence of life beyond our planet. So why not join in the adventure and keep our eyes on the skies? Who knows what incredible discoveries await us in the ever-expanding universe? Don't forget to subscribe to our channel